Hello everyone, how are you doing? How's the start of QCon been so far? All right? It's a great lineup this year, so many great talks. It's really great to be here as well, so thank you so much for your time. And if you don't mind, let's get straight on with it because we've got so much to do. In the next 20 minutes or so, we've got a whole website and set of apps for which we need to design a system for. We're talking BBC Online, where at any one moment, millions of users can be using the broad range of features it's got. This is an interesting challenge we've got. In the next 20 minutes, let's see what we can do to make it happen. So what's BBC Online? Well, the bit you might know the best is BBC News, used massively around the world. According to FeedSpot, it's the #1 news website in the world. To be honest, I've seen some other sites that claim Yahoo's the #1 news site in the world. People still use Yahoo? Well, maybe they do. But let's look for now at BBC News, right, which is huge traffic. As I say, users in the millions can turn up at a breaking news event around the world, and obviously in the UK especially. It's available in about 40 different languages. There's just a few of them, so it's a pretty massive site, but that's just the start. For people in the UK, there's BBC iPlayer, which is maybe like Netflix, but in some ways even better. Loads of live content, huge product catalogue, so content catalogue, and millions of plays on that every day. And this is just the start. There's radio, podcasts, live events, sports calls, weather forecasts, food recipes, things to make you think and to explore, and great stuff for children to grow and revise for their exams, and so much more. There's about 15 apps, as well as TV applications, CarPlay integrations, and voice applications, and all sorts more. It is this really broad range that we need our architecture to support. So our requirements basically boil down to three things. We need to handle the scale of millions of users turning up. That not just high traffic, but highly variable traffic as well, where a breaking news alert can mean large numbers turn up out of nowhere. Then we've got that breadth of content that we've just seen. We need to handle all those different content types. We're going to have multiple teams building these sites and apps, lots of stakeholders, lots of content makers, lots of feature requests. How do we scale in that way as well? And finally, this is a public service and not for profit. The BBC spends public money, so we must spend it super wisely. We must watch out for our costs. Now, there are obvious ones like the cloud costs. But let's face it, the #1 cost that most of our organizations and businesses have is people, teams, engineers. So how are we designing something so that we can move quickly, develop as fast as we can, and have a low operating cost as well? That's really key. There's our requirements then, QCon. Think we can design an architecture for that? I mean, obviously, that's not all the requirements. There's all the features we need, right? And all the content, and we need to be personalized like all modern services. What else? Non-functionals, right? Security is a given, right? And reliability. Let's focus on that one. That one's key, right? This is a service that people will rely on, so high uptime is vital. So quite a lot to look over, right? But at the highest of levels, let's have a go at this architecture. And we can do a blank sheet of paper here, because the BBC did switch off its data centers last year, moved to the cloud, so we can do a proper start again cloud native option. Brilliant, huh? We have users, good place to start. In fact, we have millions of users, we said that, so maybe we could draw it like this. We have websites and apps that they primarily consume, and as you said, we have an awful lot of them as well, right? So scale there as well. That's one side of the diagram. On the other side, we should show where the content's coming from. There are a few places, but we could probably say the main one, which is people. BBC, creative people, news journalists, TV producers, those kind of people. There are thousands of them doing all kinds of different things. So we need to give them some really good tools, content management systems to create and manage all that. Can't just be one tool because there's so much variety, and we need them to be as efficient as possible as well, don't we? Make as much great and rich content as we can. So we're going to need to give them those great tools. And well, if you don't mind, let's get rid of that that depth bit, because we know there's a lot going on there, right? We have those core bits. So what are we going to add to this cloud architecture to make it work? Well, media maybe is a place to start, right? Our video and audio and images, and how do we handle that? And if you don't mind, we won't go too much into detail in that in this talk, simply because it's worth a talk or many talks on its own, right? There's a lot of complexity there. It basically boils down to handling that media, transcoding it, preparing it, storing it, and then packaging and delivering it to the right place at the right time. So at the highest of levels, let's draw it like that. Let's focus perhaps a bit more on the other type of content, the metadata describing it, the written content like articles and food recipes, or the data-rich content like sports scores or weather forecasts. There's loads of that type, isn't it? So I suggest the first thing we need to do when we get content like that is to process it, understand it, right? What is the content? Who's it for? What does it reference? If we can understand the content and get it right now, at this point at which the content's made, that will help us when we come to make our user-facing experiences later. They need to store it, of course, in a content store. What's that? It's not going to be one thing, is it? We've already said there's so much breadth, right? This is going to be a range of different stores because there's different types of content. We might have key value stores, for example. They're nice and simple, aren't they? They work great, but sometimes things are a bit more complex than that. And I'm a big believer in using the right tool for the job, right? So a relational database might be good if your data is relational. We probably want to use things like search engines and recommendation engines as well, right? Because how people discover this content is really key. So we'll probably do many things in the storing of our content. Right, let's look at that other side, right? We said there are websites and apps. And to make websites, you need to render some HTML. Server-side rendering is essential for good performing websites. For apps, of course, they don't need HTML, but they do need a great API from which to get the right content. So we need one of them as well. And of course, both of those things will need to get the content from that content store we just drew. But if you don't mind, I'm going to add one more box in the middle called business logic. Don't like that phrase, business logic. But do you know what I mean, right? The actual logic of working out what to do. So who is the user who's requesting something? Are they signed in? Where are they in the world? What do we know about them? And then the content. What content do we have? What's live now? What events are on now? What programs are on now? What's happening? What's trending? All of these things can come together to help work out the right thing to share the user. And the business logic does that bit. So one box there so we can share that across our sites and apps. Make sense? Let's draw one more box in here. See that one there on the right-hand side. Traffic management. This is perhaps a combination of CDNs and routing layers, proxy layers, those kind of things. But if we've got a very high set of users making thousands of requests a second, we've got a broad range of services, we need to get really good at handling those requests, right? Making sure they're valid, making sure they're successful. So, for example, the user's properly signed in. Is the request a valid one? Are we under a DOS attack or something like that? It's a really key thing we need to do with that traffic management layer to get it right. Okay, looking good, isn't it? Though maybe a bit one way, isn't it? Content going from left to right, which is broadly where most stuff happens. But what about those users themselves? Maybe they can interact, right? They can certainly sign in and comment, and maybe they can even make their own content. So let's have the concept of a user store. Again, probably a bit generic, right? The place where users can track what they're doing. And once we have that set of content, we can start to offer amazing things, such as that recommendations engine above it. Let's draw an arrow into that. And analytics, right? We can start reporting back to our content makers overall how many people are accessing their content, so they can make sure they're making the right thing. Hurrah! We have an architecture. We're done in 8 minutes. Have we really hit those requirements? We had scale, didn't we? Challenges of scale and breadth of content and good value. Have we hit them? Well, maybe we're on the way, right? But we probably need a few more details to really get them sorted. Let's have a look at a couple. Let's start with caching. Hopefully not too controversial a point. Fairly standard way of helping with this stuff, right? And to me, there are 4 big advantages of caching. Obviously, scale is one of them, right? Caches can respond to normally far more responses than if you were just computing them every time. And that's what we need, right? That's important. It does it by being phenomenally quick, of course, but let's call out speed as another advantage, because we know performance is a really key non-functional for services like this, right? We know that for every second a page takes to load, 10% of people hit back and go and do something else. So a page taking 2 seconds, which is not that unusual, over 3G, for example, that's 20% of people gone on every click. Speed is perhaps the number one thing you can do to increase the amount of traffic you have. So we'll have that advantage, right? Brilliant. Cost is another one we said that's important to us, and caches, on the whole, are normally cheaper than computing things every time. And there's a 4th benefit we don't always remember when thinking of caching, but they offer a brilliant resilience option as well. Should, for example, your database be struggling under load, the cache may have something already in it from which it can respond. That serving last known good behavior, or serving stale on error, as it's sometimes called, can make the difference to a wobbly system becoming a good one. So we'll take all those benefits, right? Caching sounds ideal. Where should we put it on this diagram? Well, I think that traffic management layer is the really obvious one, isn't it, right? We mentioned CDNs before. That front door as people come in. If 2 people request the same thing and it's not personalized, why compute that twice, right? The second person can have the copy from the first. So let's definitely use a cache there. In terms of the technology, yeah, maybe CDN can play a key part, but I don't think it's just that. because we said the traffic management layer does a lot of complexity, right, around routing and understanding the user. So we're going to need boxes with all that logic in as well, and we're going to want some good cache on those boxes, right, as well. Okay, cache there. Where else? Well, we mentioned a moment ago, didn't we, that content stores, databases, they can sometimes struggle under load, a thundering herd of requests. They might not be able to handle that well. So a cache in front of the content store seems to make complete sense, right? Which technology should we use? There are loads of options here. But let me suggest Redis. We've used that for years at the BBC, and it's phenomenally fast. Super flexible too, so it gets my vote every time. Let's mark the technology for that being Redis, if you don't mind. And maybe one more place I think we could put a cache. I'm going to suggest here, in between that business logic and the web and app API rendering, just because I think there's a lot of overlap there, right? A lot of different pages and apps are going to be sharing the same information about the content and about who the user is. So there seems an opportunity there to be efficient too. And as well as the kind of efficiency speed arguments, as we said before, there's a resilience argument as well. So let's say that that business logic layer, whatever it is having a bad day, right, and being a bit wobbly. The cache in front of it can have a go at serving the last known good, assuming there is one, of course, assuming it's not personalized. And that can keep us on the air, keep us going until whatever time is we can go and fix that issue. All good? There is one catch with caches, of course, is they can slow things down because they have a habit of serving old things, right? So we need an event-driven element to this as well. See on the left-hand side, right, we've got content being pushed through the process into the content store. But if we can also push it through into those caches, or at the very least mark those caches as needing to be stale and to be revalidated, then we can correct that issue, right? So particularly if anything's fast changing, such as a breaking news event or a sports score, we can definitely get those things updated so we're not showing old content. All good? Caching, no brainer, right? Definitely needs to be part of an architecture like this. One that's maybe a little bit more controversial is the use of serverless. So there is, of course, in the cloud, we've got the virtual machines, we've got the containers, and we've got the serverless. Broadly in a line, right? From the first being where you have the most control to the serverless, where you perhaps have the least control, but in return you have the least to do. So it's that balance, right? I mean, nobody wants to be looking after servers, worrying about operating system patches or the amount of disk space, or worrying about auto-scaling, right? You just want your code to run, or your content to be stored, or whatever it is you're doing serverless. The catch is that compromise. Are we willing to accept the compromises of serverless, which I think basically boil down to three things? It can be slower, it can be restrictive, and it can be expensive. As always with technology, right? There's never often a right or wrong answer, just pros and cons of different ones. How do we choose this time? Well, let's delve a little bit into these, right? Slowness. Well, we've got a real example here. Do you remember the HTML box we had in the diagram, the web rendering service? For real, much of BBC Online is rendered using AWS Lambda. We have thousands of web page renders a second, and this is the performance we see with them. The P50, the median, that green line there, about 140 milliseconds to respond, which includes back-end calls to fetch the data, right? So I think that's pretty darn good for an average. The P99, the top 1%, that's that purple line there, up at 400 and something milliseconds. So significantly worse. But it's only 1%, and again, it might include some slow data calls under the hood, so probably all right, that one. The issue isn't those two numbers, it's the P100. It's the very slow final few requests that can't even fit on this chart. They don't even fit on the slide. They are multiple seconds long. This is the cold start problem that we get with cloud functions, where your code needs to be copied onto a new server under the hood and instantiated for the first time. Under the hood, serverless is just servers, huh? This is a genuine issue, and rather it wasn't there, right? And if you were doing something truly performance critical, you should worry about it. But it happens so rarely, and we can mitigate it against it. We can just try again after half a second, and chances are it's going to work then. So we can probably cope with that one. The restrictive point number 2 on that slide, yep, there are some restrictions, right? You have less choice of compute and storage and those things, but I think we can live with that, right? Particularly for what we're doing here and handling data and building web pages and so on. That kind of single request at once and a stateless model and basic standard CPU, you don't need any GPU or anything like that. I think we can probably work quite well with that. But that expensive point, that's a bit worrying, isn't it? Now, one of the challenges with being expensive is you have this function chaining problem where you can end up being idle. You know this one? This is where the way that all three of the cloud providers handle their cloud functions, or Lambda as Amazon calls it, how it is you pay based on time the function is running. And if your function is not doing anything for some of that time, you're effectively wasting your money. So in this case, let's, for example, say that this storage on the right takes 300 milliseconds to respond, which for something like S3 is not unusual. Say this cloud function also needs 300 milliseconds to do its processing on the response. In total, it's going to take 600 milliseconds, right? But you're only doing 300 milliseconds of compute. The other 300, you're paying for that function or that Lambda to do nothing, just to wait for that underlying storage. And if you've chained your functions, like in this one, then you might, to the point where that one on the left, for example, may need 300 milliseconds of compute itself, but it's ultimately paying for 1200 because it's waiting for all those other ones down. In this theoretical example, we're using 900 milliseconds of compute across those three functions, but paying for 3 times that. Please, cloud providers, change your pricing model, charge us less when we're not using the compute. Till that time, we're going to be careful about this chaining problem, which is a pity, right? Because this is kind of the microservice concept, isn't it? Of separate things doing one thing well. It doesn't work so well in a serverless environment. Certainly not if you're running thousands a second. If you're just running a few a second, it's just noise. But if you at scale, this really costs. And so does using a slow storage solution like this example here as well. So we need to design our service to not have this issue. It's a pity, but we can manage that. All right, so we can do that. That's one cost challenge out of the way. But fundamentally, isn't serverless just more expensive? Yeah, we've done the math for all the cloud providers. And if you compare the kind of rack rate virtual machine cost, there's many of them, if you pick a good example, against the kind of rack rate serverless cost, just the actual cost of access to CPU for a period of time. With the cloud functions or Lambdas, you're paying 2, 3, 4 times as much as if you were using the kind of virtual machine. So, not orders of magnitude, but a significant amount to worry. But is it really like-for-like comparable? Well, maybe not, because with serverless, you only pay for it when you need it, right? Let's take this standard kind of behavior of traffic coming over time, right? Quiet periods and high periods and growing in between. In the old days, when we had data centers, we needed our capacity to be about this line, right? We needed to have enough capacity to handle that highest moment, that most, the busiest moment, and we kind of needed to hope that we didn't get at a busier moment, we ran out of capacity. Then, when the cloud came along, we got autoscaling, so we were able to do something like this, right? Where we were able to respond to the amount of traffic and horizontally scale, add some more instances to cope with that. But we never could get that yellow line quite that close to the underlying blue line of the real traffic, right? Because it took a moment to spot the traffic was increasing, and then took another moment to gain your instances to give you that additional capacity. So you always had to have that special space in reserve, right? In effect, you were permanently over-provisioning with that capacity there. With serverless, of course, you're just paying for what you need. You're just paying for that blue line. Great, but you might still argue that's not 2 or 3 or 4 times as much, right? So you're still thinking serverless is more expensive. Maybe it is in some situations, but what's that yellow line? I mean, chances are these virtual machines or the containers you were using, you're not maxing out before you autoscale, right? Chances are your CPU is probably only getting to 20 or 30%. Normally, you don't want to get any higher than that because a contended CPU does not give you good performance. Same with memory and networking, right? You do not want to be pushing those limits too much. And so you are already paying for far more compute than you need. Suddenly, that 2 or 3, 4 times from a serverless point of view doesn't seem that bad. We've done a lot of math on this, and it certainly varies on the variables, right? Different systems will have different requirements. But I don't think there is a major cost issue with serverless. It may cost more. I really wish the cloud providers would make it a bit cheaper. But ultimately, you are using less of it. So in many cases, it won't be any more overall. So you can see where I'm going, right? I think there's a part for serverless to play in this architecture. Let's have a look where. Start with that process box. Do you remember what that is? When a piece of content is made, you want to analyze it and store it. What about that? Do you think that? I think so, right? I think this is the most obvious one, right? It's not that time critical. If it takes a second or 2, it probably doesn't matter. It's event driven. It's the perfect place for a cloud function, I think, to do that processing. So I'll mark that one as serverless. Thank you very much. What about the content store next to it? This isn't compute, of course. This is storage. Can this be serverless? Well, all the cloud providers have some options around here, don't they? So Azure's got its tables, and Amazon's got its DynamoDB, for example. So key value stores seem to be well suited for this. Not always perfect, but on the whole, there are some serverless options there. But when you get to some of the more sophisticated storage, relational databases, and search engines, and recommendation engines, it becomes a little harder, this one. The true serverless dream where you just have infinite capacity as you need it, where you're not having to worry about with how many replicas you've got or what your sharding situation is. We're not quite there, are we, with all of those? I'm sure the cloud providers are working hard, but it's a bit of a mixed picture here, isn't it? So let me suggest this is serverless where possible. Okay, let's move on. What about this traffic management layer? Remember, this is has a bit of handling lots of concurrent requests, so a high network, high throughput, relatively low CPU because it's passing most things on. This, right, not a good serverless option, is it? I mean, there are kind of API gateway style solutions the cloud providers have, but we want a bit more control than that, so we wouldn't want to use a cloud function here. I'm going to suggest this is probably good for sticking with the virtual machines, or maybe you could do it with containers, right? But we want quite a lot of control to get this right because there's a lot of traffic. What about these ones to the left then, the rendering of the web pages and the app APIs? Harder one, this one, isn't it? Because we want the scale. We know that thousands of users come through, and we're going to need the compute in order to render the pages and so on. But we have that issue, right, with the function chaining, right? We know that these services will be waiting on the downstream ones, such as the content store, to respond. And if that's slow, then we'll be paying just to sit and wait for it. We had to put those caches in, right? And Redis responds in under a millisecond. So we're hoping most of the time there won't be much to wait around for, right? And we could really do with that compute on demand without having to worry about auto-scaling, because this is the bit we really need to scale, right? So I'm going to suggest this is a pretty good choice for serverless. And that final one in the middle, business logic, by the same argument, I think there's a good serverless option there as well. We won't do the red bit at the top and the green bit at the bottom just because we're short on time. But you get the principle, right? Looking at those white bits, how much is serverless? Half? More than half? It's a fair chunk, right? Not everything. But it's a serverless where default philosophy. Use it for all the benefits until you've proven that for that use case, it doesn't make sense, right? It's too expensive, too inflexible, or whatever. Cool. So we have some serverless in there, quite a lot. And those teams then building their systems can worry about the functionality of what they're doing, rather than working out the best way of configuring everything from an operational point of view, right? All good. We have an architecture. Thank you very much. But are we ready to just print it out and deliver it to our teams? Or do we think maybe we need a little bit more? I'm thinking maybe we do. When we've done this for the BBC for real, the one thing we found that was critical was to make sure that we then had clear ownership of everything that needs to happen. Kind of obvious, right? But what the architecture diagram is and what actually needs to be owned aren't necessarily the same thing. So for example, there are core capabilities that we must get right. How do we host it? How do we do our build pipelines, CI/CD? How do we do our analytics? And we won't list them all, but you get the idea. There are common concerns we need to worry about, like security and accessibility and so on, right? I mean, we need people to own these issues. We can't all be experts in all of them, but we need to make sure they happen. We've got common capabilities that we want to have across our sites and apps. For example, video clips, how are we handling them? We want one team to own that and do it really well. In fact, we want a team to own all of the things on these diagrams, right? And here's the fourth and final circle of the things in them. They all need to be owned. So for example, weather, that one over there, we need someone to own weather forecasts. That team, say you're on that team, you're going to want to use lots of the other things in this diagram, right? You're going to need to consider hosting and build pipelines and maybe video clips, right? But you don't want to have to resolve those problems. So because other teams are owning them, they can provide that as a service for you, allowing you to focus on the things that really matter to what you're doing that's different, in this case, weather forecasts. It's kind of obvious, this, right? But by making that list of everything that needs to happen and then organizing our teams around that to make sure everything's owned, it makes a difference for this being a deliverable thing rather than just an architecture. And by ownership, of course, we mean proper end-to-end. You design it, you build it, you operate it. If it breaks, you get rung up. The full DevOps ownership lifecycle. And you get that right. And you get what I love is one of the great mantras, I think it came from Perl originally, is make the common things easy and the specialist things possible. What do we mean by that? Well, if you're a team building something, you want most of the problems that have been solved elsewhere to just be available for you to use, right? Which could be video clips, could be monitoring, right? It could be anything. But if 80% of the time you're on the same path as everyone else, then hopefully you will build up this ecosystem of features and capabilities and best practices that you can all use. And that way you're not all reinventing or anything, not all coming up with your own build pipelines, for example, because teams are sharing things where they can. But you don't want to overgeneralize, right? There's going to be 20% of the time when you're doing something different. Maybe you're doing machine learning algorithms and no one else is. Maybe you're doing video transcoding. You're going to need a different process, different tools. And that's going to be okay too, right? You're trying to get that best of both, where that common stuff is easy because everyone's following best practice and being as efficient and as possible, but still allowing that specialism so you can have that breadth where you need it. Let's take one final look at our lovely diagram to show how that works in practice. Say you're a new team that needs to make a new website. No worries, we have the place where we do that. You can extend that or clone it as necessary. But say your website needs to be radically different. Maybe it's, I don't know, some 3D world that needs to happen. No worries. We can go off and make something different if we want. Maybe pick different technology, not use serverless, whatever. We can extend our architecture some of the time at least to work in a different way. Maybe a CMS is needed that's different as well. No worries, we'll do that. Getting that best of both, right? Where we have that consistency, that efficiency, so we can be as fast and optimized as possible. But still allowing that breadth. That's the beauty of microservice architectures, right? Fundamentally. And if you get that balance right as teams, where you're allowing that golden path, so everyone's showing where they can, but being different where they need it, we're hopefully getting that efficiency argument right as well, right? We're allowing everything to happen. We're not duplicating unnecessarily, and we're ultimately creating what should be a nice, fast, reliable architecture. We're done. Thank you so much. Does BBC Online really like this? Yeah, pretty much. I mean, it's 25 years old, so I won't lie. There's some tech debt, right? There's some of the old systems aren't quite like this, but at its heart, this is it. If you were to go and visit the BBC homepage now or read a news article, that web page would have been rendered in a Lambda. It would have been cached in Redis. This architecture you see is powering hundreds of millions of requests every day in a reliable way, touch wood, and an efficient way too. It's not rocket science, but it works. All right, thank you so much, everyone. We have looked at that architecture, the highest of levels, haven't we? But thank you for going through that with me. We've looked at some of the tech choices, particularly serverless, and very briefly at the end, we looked around, how we organize ourselves, making sure everything is owned end to end to make it happen. Thank you so much for watching, and I'll see you soon. Wow, there's been so many questions, so many great ones as well. A few questions about the content management system. The BBC builds its own, basically. Do I dare press the video, but is that going to work? Who knows? The BBC builds its own content management system, so it's kind of headless in a way. We have a team building that so we can get the workflow exactly right for our content makers, which then effectively they create an API or a feed in effect, which then go into the storage to which we make our websites and apps. Obviously, building your own content management system it's got a bit of history to it. There are some brilliant ones out there, but that's just what we do. There were some questions there about testing. How do we test the serverless stuff? So we used to, in the old days, kind of have a QA environment, a test and stage environment, in which kind of things would come along. And we still have that. We still have one pre-production environment. But one of the nice things, of course, about serverless is every pull request can have its own separate set of tests running. You can create an environment just like the production one, and you can have at any point hundreds of them, of course, because they're all just copies of your function, your Lambda. So we do that. The CI/CD pipeline does that automatically. We still have a moment when it gets to that QA environment where we can press a button to launch. So it's not completely automated to live, but it is just a one-click deploy once we're happy with it. We don't do anything clever like blue-green or kind of rolling out deploys. It's something we'd love to do, but we've always found it, because it's so easy to roll back to a previous version, we found it just easier to roll out 100%, give it a go, and you notice pretty quickly if something's wrong and you can roll back. It's not the smartest solution. We could do something clever there, but we actually find that to be good enough for now and something we'll work on. What CI/CD pipeline do we use? Most of what we're doing is on Amazon, so we've basically moved to their kind of code build code pipeline things just because it's so managed. We used to do a lot of Jenkins, but there's quite a lot of overhead in keeping that going. So we have gone a bit Amazon with the CI/CD stuff. What other questions did we ask? Sorry, there's so many of them. It's been wonderful, your feedback. Thank you. Security in the architecture. Yeah, we didn't cover that. Clearly, there's a lot around access control. Obviously, with serverless, it really helps because you don't have the boxes for which you need to worry about who has access. But we have our own process by which, when we do have those virtual machines, to make sure that we how you access those ones as well. We go the full on with the IAM access, right? Least privilege, making sure that each function and each server and the rest of it already have access to what they need. We do quite a lot, of course, with handling requests into our site as well. Being a high-profile site, we do get some interesting attacks on us, so we need to. So there's a whole bit of thing there. We could do many talks on the security. Finding restrictive about serverless. Well, there's a whole set of things here, isn't there? Right, you have a limited amount of compute variation, right? You can't do limited amounts of GPU, for example. Not a lot of storage. You can't be stateful. That's a really key one, right? If you do something, you can't handle concurrent requests at once. That also ties into why we use the virtual machine for the traffic management layer, right? High numbers of requests at once. Perhaps could do it with serverless, but it kind of doesn't make sense when you need to do something that involves a lot of concurrent networking requests. And I am aware that we are being told that we have to be very much to time on this, and we're hitting, I think, 22 the hour. So there is the breakout room in Zoom, so we could go and join that. But otherwise, poor Charles is still having tech issues, I think. Thank you so much for your time. We can chat along in Slack as well for the rest of the conference. So if anybody wants to, I'll be around for the whole 2 weeks. I'll see you soon.